You obviously know that a lot of objects float, from the smallest one, feathers, leaf, apples, ball, to the biggest one, canoes, ships, boats, icebergs. But have you ever wondered what makes them float? Don't worry, I got the answer for you. It's Aya Elmir, 16 years old from a bad city, and today I'm gonna be explaining to you guys one of the most important theories the world have ever seen, Archimedes' principle. About 2000 years ago, Archimedes, a Greek mathematician, physicist, and inventor, was charged by Hiram, king of Sicilian city, to discover whether the royal crown was made of pure gold or not. So one day, as he was entering his bathtub, he noticed that the level of water rose. Based on that, he discovered that the volume of water displaced by an object is equal to the volume of the submerged part of the object. This theory, known as water displacement theory, allows him to solve this problem. Let's do a little experience. Take a ball, put it in a bowl of water, and try to push it down. You notice that there is an upward force pulling up the ball. When you release it, you can see that it suddenly returns to the surface. This force is actually called buoyant force. Let me call this Fa. That has, of course, a point of application A, which is the center of the emerged part of the object, a line of action, the vertical line passing by A, an upward direction opposite to the object's weight direction, and finally a magnitude that we currently don't know how to calculate it. To learn more about this magnitude, let's see what Archimedes' principle says. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. We all know that the weight of an object is equal to its mass multiplied by the acceleration due to gravity, little g, which approximately equals 9.8 Newton per kilogram. And if we place it in our equation, we find that the buoyant force magnitude equal the weight of the volume displaced magnitude equal the mass of the volume displaced multiplied by little g, which implies using the density's law, Fa equal PVD equal the density of the liquid multiplied by the volume displaced multiplied by little g. So this equation, the buoyant force magnitude equal the weight of the volume displaced magnitude equal the density of the liquid multiplied by the volume displaced multiplied by the acceleration due to gravity, will allow us to calculate Fa magnitude. Keep in mind that the weight of an object P is different from the weight of the volume displaced by this object's PVD. Also remember that when the weight of the object's magnitude P is superior to the one of the buoyant force Fa, the object will sink. But when Fa magnitude is superior to P magnitude, it will float. Finally, when Fa magnitude equal P magnitude, the object stays stable in water like a submarine. But there are also some other conditions for this equilibrium. The two forces must have the same line of action and two opposite directions. We can summarize all those three conditions in this equation. Force Fa equal minus force P, which implies that force Fa plus force P equals vector 0.